Welcome to Chapter 2, focusing on measurement and problem solving. The uncertainty of a measurement is indicated by the last reported digit. For instance, an average global temperature rise of 0.6 degrees Celsius means the true value is between 0.5 and 0.7 degrees Celsius. Scientific notation is made up of two parts: a decimal part, which is a number between 1 and 10, and an exponential part, which is 10 raised to an exponent nan. A positive exponent means 1 multiplied by 10n times, while a negative exponent means 1 divided by 10n times. These exponents help in writing very large and very small numbers compactly. To convert a number to scientific notation, first, find the decimal part by moving the decimal point to get a number between 1 and 10. Then, multiply this decimal part by 10, raised to a power that reflects the decimal point's movement. If the decimal point moves to the left, the exponent is positive. If it moves to the right, the exponent is negative. When reporting scientific numbers, the first few digits are certain, and the last digit is estimated. Greater precision in measurement means a higher number of significant figures. If a balance has markings every 1 gram, we estimate to the 10th place. To estimate between markings, mentally divide the space into 10 equal segments and estimate the last digit. This reading, for example, is 1.2 grams. For a scale with markings every 0.1 gram, we estimate to the 100th place. The correct reading in this example is 1.26 grams. In a correctly reported measurement, all non-zero digits and interior zeros are significant. Trailing zeros after a decimal point are also significant. However, leading zeros are not significant. Exact numbers, like those from counting discrete objects or defined quantities such as 1 inch equals 2.54 centimeters, have an unlimited number of significant figures. Here are examples of counting significant figures. Note that the number 100,000 is ambiguous regarding significant figures. When performing calculations, the result must be rounded to reflect the significant figures of the data. For multi-step calculations, only round the final answer to prevent errors. When rounding, use only the last digit being dropped to decide whether to round up or down. Round down if the dropped digit is 4 or less, and round up if it is 5 or more. For multiplication and division, the result should have the same number of significant figures as the factor with the fewest significant figures. In this multiplication example, the intermediate result of 45.0118 is rounded to 2 significant figures, 45, because the least precisely known factor, 0.10, has 2 significant figures. Similarly, in division, the intermediate result of 0.96590 is rounded to 0.966, which has 3 significant figures, matching the least precise factor, 6.10, with 3 significant figures. For addition and subtraction, the result should carry the same number of decimal places as the quantity, with the fewest decimal places. In this addition, the intermediate answer is rounded to 2 decimal places, giving 9.21, because 5.74 has the fewest decimal places. In this subtraction example, the answer 0.835 is rounded to 1 decimal place, resulting in 0.8, as the least precise quantity, 4.8, has 1 decimal place. For calculations involving both types of operations, perform steps in parentheses first. Determine the correct significant figures in the intermediate answer without rounding, then do the remaining steps. In this example, the subtraction is done first, and the least significant figure is underlined. Then, the multiplication is performed, and the final answer, 12, is rounded to 2 significant figures. The International System of Units, or SI units, is the standard unit system for scientific measurements based on the metric system. The table shows some basic SI units. The meter, the standard unit of length, is defined as the distance light travels in a vacuum in 1/299,792,458 of a second. The kilogram, the standard unit of mass, is defined by a physical block of metal kept at the International Bureau of Weights and Measures in France. The standard of time, the second, is defined using an atomic clock as the duration of 9,192,631,770 periods of radiation from a specific transition in a cesium-133 atom. Mass is a measure of the quantity of matter and does not change. Weight is a measure of gravitational pull on matter and varies with gravity. SI prefix multipliers are used to express large or small quantities in standard units. The prefixes represent different powers of 10. When choosing prefix multipliers, select one that makes the measurement convenient, ideally similar in size to or smaller than the measured quantity. For a short chemical bond, picometer is the most convenient choice. Volume is a derived unit, formed by cubing a unit of length. Examples include cubic meters, cubic centimeters, and cubic millimeters. Solving problems and reaching an equation often requires critical thinking. Problems can be divided into two types: unit conversion and specific equation types. Many problems involve unit conversion, changing a quantity from one unit to another. Dimensional analysis uses units as a guide to solving problems. Always include units with numbers and treat them like algebraic quantities, multiplying, dividing, and canceling them logically throughout the calculation. Most unit conversion problems follow this general format. The given quantity is multiplied by one or more conversion factors to yield the desired quantity in the new units. Conversion factors are created from two equivalent quantities. For example, since 1 inch equals 2.54 centimeters, we can form a conversion factor that equals 1 to convert between these units. Always check your final units and make sure the answer's magnitude makes sense. Conversion factors can be inverted because their value is 1, and the inverse of 1 is 1. A solution map is a visual outline of the steps needed to solve a problem. For unit conversions, the map focuses on how to convert from the starting unit to the ending unit. Here are examples of solution maps for converting between inches and centimeters, and from centimeters back to inches. A general problem-solving strategy involves 4 steps. Identify the given information, identify what you need to find, devise a solution map, and then execute the calculation. In graphic form, this progresses from given to find via the solution map. The detailed problem-solving strategy involves 4 steps: sort the information, strategize by creating a solution map, solve by carrying out the mathematical operations and checking significant figures, and finally, check if the answer makes physical sense and if the units are correct. For multi-step unit conversion problems, each step in the solution map requires a conversion factor. The conversion factor's denominator contains the previous step's units, and the numerator contains the next step's units. Once the solution map is established, follow it to solve the problem, applying the conversion factors sequentially to transition from the initial unit to the final desired unit. In some cases, unit conversion is required in both the numerator and the denominator of a given quantity, such as converting a speed from miles per hour to kilometers per second. When converting quantities where the units are raised to a power, the conversion factor must also be raised to that same power. If we know the relationship between meters and decimeters, we can cube both sides to get the conversion factor for cubic meters to cubic decimeters. Density, a physical property, explains why materials like titanium and iron have different masses for the same volume. Titanium is less dense than iron, meaning it has less mass per unit volume.